Hey guys, so today's lesson is on compound inequality. All right, so the first three lessons from the chapter we were only dealing with one inequality at a time and one graph. So now compound inequality represents we're doing two graphs in one. Okay, so we're gonna be dealing with two inequalities in one, and we're gonna have to graph these two graphs in one graph. Okay, so there's two types of compound inequality. The first one that we have is a compound inequality containing the word and. Okay, is only true if both inequalities are true. So anytime you have an and, it represents an intersection. Okay, it represents that both inequalities will have to be true, okay, in order for it to represent a true statement. So their graphs will overlap, and basically it will be an intersection. So an and represents overlapping graphs, or we could say intersections, okay? So let me give you an example. This is what we have done. When I give you one inequality that says x is greater or equal to 3, you will plot the point at 3, close circle because it has the equal, and it says greater, so I'm going to be shading to the right, okay? Let's look at the second one. It says x is less than 7, so I will plot it at open circle at 7, and it says less than, so I will be shading to the left, okay? But now, because we're dealing with compound, you will see something like this. If you see an inequality that is together, this represents an and, okay? So how do we read this? We read it in terms of the x, okay? So you have to look at the x. So look how I'm gonna read it. X, I'm going this way. X is greater or equal to 3. So I'm gonna plot my point at 3, close circle, right? Then here it says x is less than 7. So it will be an open circle at 7. So at the 3, it said x was greater. That tells me I'm going to be going to the right, okay, of my graph. But then it says x is less than 7. So now at this point, I'm going to go to the left. As you can see, okay, they're overlapping. They're intersecting. Okay, so basically when you have a compound with the word and, I'm going to know that most of the time my graph will be in overlapping. Is everything in between. Okay, this represents everything in between. Okay, and that's how, that's what I want to see for your classwork and your homework. I'm going to be giving you a compound inequality in which you're going to solve. Okay, after you solve, if it represents an and, my inequality should be written like this. Okay, then you plot the graph. All right. Another type of compound inequality is when we have the word or, okay? A compound inequality containing the word or is true if at least one of the inequality is true. So, and for the and, both have to be true because they're represented and overlapping. For an or, only one of them has to be true, okay? Not both, all right? And that's the difference between it. So basically, the graphs represents a union of the graph of two inequalities. It's a union because only one of them has to be true. So let me give you an example. X is greater than 2. How will you have graphed that? An open circle at 2 going to the right. Here, x is less than or equal to -1. You will have done a closed circle at -1 and going to the left, all right? Now, I'm going to have a compound, okay? When you have a compound that represents an or, you will always see the word or separating the two inequalities, okay? So let's graph it. It says x is greater than 2, open circle, going to the right. Okay, this one says x is less than or equal to -1, so it will be a closed circle, and it will go to the left. So most of the time, my graphs will go in opposite direction, okay? And this is my answer for this problem, okay? You show me the graph. All right, let's do some that in which you have to solve, okay? All right, so let's look at this one, all right? I have a compound inequality with the word or. So I know I have a union, all right? Look at this one. X is already solved. X is by itself. That tells me I'm just gonna have to plot it, all right? But this one, is my X by itself? No. So I need to see the work in which you're gonna get X by itself. Some of you like to skip steps. And this is why I'm telling you, when I email you back saying I didn't see your work, that represents you're not showing me your thought process of how you isolate that X, all right? So here I need to subtract, okay? Because I gotta do the opposite of adding. I get 4x is less than 8, okay? Then I divide by 4 to both sides, and I get x is less than 2. Or x is greater or equal to 9, okay? So now this is my answer. Sorry, it should say x. Okay, so this is my answer. I isolated the x here. This one, the x was already isolated, so I didn't have anything to do here, all right? But now I got to bring it together. So I'm going to label my graph, okay? This is why I told you that it's very important that you know how to label the number line, okay? So let's go. So this says x is less than 2. Open circle, got to graph to the left. Here says x is greater or equal to 9, close circle, and is greater, so I gotta go to the right. So my full complete answer is this and my graph. So for class work, what you're gonna be emailing me is your work, the solution, and the graph for every single problem. Is that understood? All right, so now let's go to example 2. You see how this compound inequality is written? This represents an and, okay? I see 2 inequalities here. That tells me I have to solve for both, okay? So again, you are solving, let's say I cover this. This represents 1, okay? If I cover this, this represents the second one. But we could leave it all together and just solve it. So my whole point is to isolate the P, okay? What do I have to do here? What's the opposite of adding the 7? Subtracting the 7, right? So I have to subtract the 7 on where it started. I have to subtract the 7 on the right side of this inequality and subtract the 7 on the left side of this inequality because I have this one and this one. Okay, so you are subtracting 7. This will cancel. Then I'm gonna do my work vertically. Okay, so this will give me 15. Okay, 22 minus 7 is 15. Then I'm going to rewrite it, and this gives me negative 12. Okay, let me repeat that. My whole purpose is to isolate the P because I want to find the solution set. Okay, what's the opposite of adding a 7? Subtracting a 7. So I got to subtract the 7 on the side that it started with. Then I got to subtract it here, the other side of this inequality, and here. All right, so now how do I get the P by itself? By dividing. So I gotta divide it to everything, okay? So negative 12 divided by 3 is negative 4, less than P, 5, okay? So now my next step, this is my solution. My next step is let me label my number line. So I put the 0 here, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4. Okay, so how do I read it in terms of the variable? This says P is greater than negative 4. So open circle, greater, I know I got to go to the right. Okay, I'm just going to graph shade a little bit. All right, just so I know in the direction that I'm going. Then I got to read the other inequality in terms of your variable. So P is less than or equal to 5. That tells me close circle at 5. And it says less than, so I got to go to the left, okay? So this is my graph, okay? Open circle at negative 4, close circle at 5, and everything in between those two numbers. So as you see, I'm showing my work, boxing in my solution set, then I graph. All right, here's the last one. so you guys could start your classwork of the 4 problems. All right, here tells me it's an or. Okay, so most likely my graph might go in opposite direction. It's not always the case, but most of the case. Okay, so here I gotta isolate the t, so I gotta subtract 14 to both sides. I get t is greater or equal to 1, or then I solve for t here, and I get t is less than -1, okay? So now I'm gonna label my graph. So I'm gonna put the 0 in the middle, okay? So let's read it again. T is greater or equal to 1. Close circle. It's greater. I know I'm going to the right. This one says t is less than -1. So open circle at -1 and is less than. So I know I'm going to the left. All right. So my graph is going in opposite direction. So this is the complete work that I would like to see for today's lesson.